So as I read this, you are going to want to get out a highlighter or a pencil, and you're going to want to highlight and underline the things that I say to underline as you're watching this video. So, paragraph number 1, the study of the origin, structure, and future of the universe is called cosmology. Please highlight that. Astronomers believe that about 14 billion years ago, nothing existed. No energy, no matter, and no space. Scientists search for a way to explain what happened, how everything began, and where matter came from. With much observation and experimentation, scientists created a theory called the Big Bang Theory. The Big Bang states that the universe, as we know it, started approximately 14 billion years ago, when the entire universe was confined to an infinitely small, dense, hot object. Under intense pressure, this object expanded, hurling the massive amounts of its material it contained in all direction, creating matter, space, and time in the universe within an instant. So if you would, please highlight this last sentence. Paragraph number 2. One misconception about the Big Bang is that it was fiery and a loud explosion. It was more likely comparable to a very small balloon being inflated to an enormous size. Just like the balloon starts small and expands outward in all directions as it's inflated, our universe is expanding outward in all directions. When this hot, dense, and infinitely small object began to expand during the Big Bang, it grew from a size smaller than a single atom to the size larger than an entire galaxy. This universe kept on expanding, larger and larger, growing at an incredible rate. Please highlight the first sentence. Paragraph number 3. As the universe expanded and cooled early on after the Big Bang, energy changed into particles of matter and antimatter. Please highlight that sentence. These two opposite particles destroyed one another, but some matter survived and cooled to form protons and neutrons, which created hydrogen and helium gas. Also, highlight that. Eventually, the universe became cool enough for the gases to condense into stars and galaxies. Paragraph number 4. Like all scientific theories, theories about the beginning and the end of the universe must be tested by observations, be repeated experiments over time, and have sound scientific evidence. Please highlight that sentence. When scientists first proposed the hypothesis of universal expansion, they needed to find evidence to support it and change their hypothesis into a theory. There are several main pieces of evidence that support the Big Bang Theory, including the expansion of the universe, presence of cosmic microwave background radiation, and the composition of the universe. Paragraph number 5, expanding galaxies. Galaxies are systems of billions of stars, gas, and dust that are held together by the force of gravity. Please highlight that. Our solar system is part of a spiral galaxy called the Milky Way. Some galaxies are clumped together and are called galaxy clusters. The universe is made from billions of galaxies and contains billions of stars, planets, and other astronomical objects. Paragraph number 6. One of the most astounding discoveries of modern astronomy is Hubble's law. American astronomer Edwin Hubble made the observation of the movement of distant galaxies and published Hubble's law in 1929. Hubble observed that most galaxies are moving away from us. Hubble's law states that the universe is expanding and that galaxies are racing away from each other at speeds that increase with increasing distances from each other. In other words, galaxies are retreating from us at a speed that is proportional to the distance. So, this is just me inputting here. The farther they are away, the faster they move. Please highlight Hubble's law. Paragraph number 7. Hubble's law says that galaxies farther away from us are also moving away faster from us. A galaxy 3 times as far away is moving at 3 times as fast. Evidence of Hubble's law is the redshift of wavelengths of light that are moving away from us. Light travels in wavelengths. The redshift of light from distant galaxies is the evidence that the universe is expanding. Please highlight this paragraph. It talks about redshift. Redshift are longer wavelengths. Paragraph number 8. Redshift occurs when light traveling to Earth from other galaxies appears because of the distances between Earth and the galaxy is increasing, causing the wavelength of that light to stretch out over lower frequency. It's important to highlight that. And then take a look at the picture too. On the other hand, a wavelength of light that is moving towards us is compressed, increased its frequency, and appears blue. The farther away the galaxy is, the more light is redshifted. Redshift of light gives scientists information on the speed and direction of the galaxy as moving. So highlight that statement too. This in turn tells scientists that galaxies are not only moving away from us, but they are also moving away from each other at increasing speed. Supporting evidence for the Big Bang Theory and likely an explanation for redshift is that the whole universe is expanding, starting with a single dense point of matter and energy. Here's another thing that you should highlight. Put that in your slot. Paragraph 9. Paragraph 9. To help visualize how the universe is expanding, imagine a loaf of raisin bread dough that has been set out to rise for a few hours. As the dough grows, doubling in size, so does the distance between all the raisins in the dough. No matter which raisins you observe, it will move away from all other raisins. Likewise, no matter where an object is located in the universe, every other galaxy, except those in the same cluster, will be moving away from one another. So again, if you would highlight this. Edwin Hubble advanced our understanding of the origin of the universe, and the Hubble Space Telescope is named in his honor. Paragraph number 10. Cosmic microwave background radiation. According to the Big Bang Theory, the universe was once condensed into an infinitely small point, rapidly expanding and then cooled in a short period of time. Immediately after the Big Bang, the universe was too hot to contain atoms. Once cooled, nuclear fusion began fusing the hydrogen nuclei into helium atoms. As these atoms form, they released energy uniformly throughout the universe. So I would like for you to highlight this statement. The energy was released as light waves that were stretched or redshifted into lower energy waves called microwaves. These microwaves are just now reaching the Earth almost 14 billion years later. These microwaves, called cosmic microwave background radiation, are so very far away that they are the oldest signal that we can detect on Earth. Paragraph 11. Cosmic microwave background radiation, CMBR, is microwave radiation in the electromagnetic spectrum that is left over from the Big Bang. It fills all areas of the universe. CMBR began traveling through space when the universe was only about 380,000 years old, but now it fills all areas of the universe. During the Big Bang, a lot of high-energy radiation was created, and then the universe became larger and cooler. Therefore, high-energy photons lost most of their energy, becoming microwave radiation. Cosmic microwave background radiation is the radiation that has been traveling without coming into contact with anything since about 380,000 years after the Big Bang, and it fills the entire universe. I think what I'd like you to highlight there is this sentence. Thank you. See you later. Paragraph 12. In 1964, radio astronomers Arno Penzias and Robert Wilson first detected CMBR accidentally. The radio antenna in their lab in New Jersey picked up an odd buzzing sound that came from parts of the sky at all times. Penzias and Wilson were puzzled by the sound and tried to eliminate all possible sources of interference, including removing some pigeons who were nesting on the antenna. It wasn't until they exhausted every possible explanation of the sound's origin that they realized they had stumbled upon something big. It was a huge discovery because they were the first to spot CMBR, the predicted thermal echo of the universe's birth. Their landmark finding is supported by evidence of the Big Bang Theory because its existence explained that the cosmos did indeed grow from a single point about 14 years ago. Paragraph number 13. To understand the connection between the Big Bang Theory and the CMBR, you have to think about a kitchen oven. When the door is left open after the oven has been used, thermal energy is transferred throughout the kitchen and the oven cools. Eventually, the room and the oven become the same temperature. According to the Big Bang Theory, the thermal energy from the original explosion was distributed in every direction as the universe expanded. This cosmic microwave background radiation now fills space. Please highlight these two last sentences. Paragraph number 14. Another piece of evidence for the Big Bang Theory comes from the composition of matter in the universe. So highlight that. As the universe expanded and cooled, an abundance of elements were created by nuclear fusion. Nuclear fusion is the process where less massive nuclei of atoms combine into more massive nuclei. This product creates new elements and releases a tremendous amount of energy. Scientists have traced the expansion of the universe back to a time when it was smaller than an atom. In the earliest moments after the Big Bang, there was nothing more than hydrogen compressed into a tiny, dense, hot, and pressurized smaller objects than an atom. Within the first second of the Big Bang, the universe cooled enough for protons, electrons, and neutrons to form. Now I'm in paragraph 16. About 100 seconds after the Big Bang, this is important, the temperature of the universe had cooled enough for nuclear fusion to occur. Neutrons and protons began to cluster together to form atoms of hydrogen. When hydrogen collides together, they underwent nuclear fusion, and fusion is the putting together to create a helium atom. The collisions continued and were able to form heavier atoms such as lithium. Within 10 minutes after the Big Bang, the universe had cooled so much that nuclear fusion could no longer occur. Astronomers measure the ratio of hydrogen and helium and other elements to the universe. The Big Bang Theory predicts how much of each element should have been made early in the universe. By studying very distant galaxies and old stars, scientists came to the conclusion that our universe was approximately 95% hydrogen and about 5% helium. When scientists calculate the ratio of hydrogen to helium in today's universe based on the conditions of the early universe, the ratio almost exactly match. These calculations support the Big Bang Theory states about the early composition of the universe. Paragraph 18. Redshift, cosmic background microwave radiation, and the composition of the universe are all pieces of evidence that support the Big Bang Theory. According to the theory, about 14 billion years ago, all the continents of the universe were compressed under tremendous pressure, temperature, and density into an extremely small volume. Then the universe rapidly expanded and cooled, and matter began to come together to form galaxies. Redshifting of light demonstrates Hubble's law, which states that the farther away an object is, the faster it is moving. Cosmic microwave background radiation is leftover energy from when the universe first expanded. Over time, as the universe cooled, tiny bits of matter formed. Hydrogen underwent nuclear fusion to form the first stars and galaxies, and the composition of the universe today matches the ratio of the hydrogens and heliums that scientists predicted our universe's early history. It is believed that as a result of the Big Bang, all the galaxies in the universe are still moving away from one another.